Welcome back, everybody. Are you ready to do this one more time? I think I am. Let's go. So we're fresh off of truing out the center hole in the flywheel in the prior episode. So today we begin by crafting a replacement splined hub. So we have our new splined hub fixed into the small lathe on the arbor. We also set that up last time. So our first target diameter for the outside is going to be 1.850. We are 2.5 inches right here. We're still 2 inches down here. So that means we don't even have to start measuring until we've taken this whole outside diameter down to one straight size. And then we'll start checking progress after that. So we're just going to be making chips for a while. Okay, we are at our initial 1.850 target. So now that you look at both of those set screw holes, you can kind of see where we're going to start shaping this thing. And only the very top edge of this new splined hub is going to be that big around. Because you look at what they were doing on the old one when they were putting all these staking marks around the top of it. They were creating these little bump outs, okay, that would come to rest in this bevel that's right around the top of the hole. And what that did is it prevented it from falling all the way through, helped to position it to do the rest of the work. We're doing the same thing here, except for we're not going to rely on just a few staking bumps. We're going to make a raised ridge that goes all the way around the top perimeter of this so that when we drop it in the hole, it'll come to rest on that bevel and it won't be able to fall through. There we are. Just a little bit of a ridge up there. It can't be very big because we don't have a lot of real estate to deal with, but that pass also hit the second target, 1.815. That's going to be our press fit into the flywheel. So we're basically done to about right here. So now we need to start replicating the bevel and then trimming to overall length. When I get close to that taper, I have to keep backing it off because it starts jamming chips. Starting to feel a chatter. We're about to break through the splines, probably on the next pass. Yep. Okay. Now we decide if we want to do the interrupted cut all the way around and just mill the rest of those splines off, or you can take it out and hacksaw them off and just file the end. That might be a better option still. We'll see how the turning goes. Just ease down on it. Got them all off. One thing we need to do right now is test the fit of the splines. And we're going to clock this in all 6 positions, because once we put this in the flywheel, it's going to be a lot harder to judge. So we just want to make sure we have good float, good click there. And that's the one saving grace about these spline couplings like this. You've got enough natural wobble built into them. You can blur the lines on accuracy just a little bit if you really have to. So, all right, and that's where we started. Happy with that. So compare it with the old one. You can see the definite similarities. We just beefed this one up where it needed to be. And instead of having to stake around the upper perimeter, we've got our small little ridge that runs around. So that'll bottom in the chamfer right there. And that's mainly just for the installation process to help to locate it. This is not going to be required for any kind of holding later on. So happy with all that. Of course, the splines are much better in the new one than they are in the old one. The drive sides there took it pretty hard as well. So we've got a good press fit. I built about 2/1000 into that. So it's definitely not going to drop in yet. Final step of the day, because we're just about ready to hang it up out here. We'll come out here to the shop fridge, freezer section. Now throw it down in there. Let it get nice and cold tonight. That should shrink it up. So hopefully tomorrow morning, we can get the door closed. We'll come right out here and we'll just drop it right in. So pick back up tomorrow. Well, it snowed again. All winter we've had spring. Now that it's spring, it's been all winter. Let's see what the temperature is in here. Yeah, we're about 2 below 0 Fahrenheit. Are we ready yet? Will we drop in? Not quite. Let's give it a little bit of rapid help. Make sure we got our set screws lined where we want them. Really thought that would have dropped in, but it's home now. Likely would have taken a press if it was all room temperature. So we'll give that a few minutes to acclimate, tighten in, and we'll come back. Everything still looks good here. It's been a few minutes. So now I want to snug the 2 set screws that are in. You probably aren't going to see them from your vantage point, but they're there. And again, these are not meant primarily to hold this collar during operation, more to just assist in holding it in position during the restaking process that we are about to begin. But as long as they were there, had provisions for them, I decided they would be good to use. So, kick you all up just a little bit so we can get a little better view of the back side. And yeah, liking that too. Looks good. So lay this down here, pivot you back down. I want to show you, I made this gasket template of the back of the crankshaft, and I wanted to show how much room we have to work with around the perimeter. Plenty of room to do a restaking in here and take out those old threaded holes. So we will move on to that. And we're back on the milling table. My plan now is to take these old 5/16 basically Dutch key lock bolt threads out to the next size up. which will be a 3/8 by 16. So we've loaded a 5/16 diameter end mill into the collet because 5/16 is the drill size for 3/8 by 16. So this will hopefully round everything out. We'll take the partial threads out of the flywheel portion, and then we will continue on with the new bore that goes down the side of the collar. So I will use some cutting oil here. It's going to be kind of an odd, goofy cut, especially on the steel side. It should carry it the rest of the way around to the cast. Usually prefer to mill cast dry, but in this case, well, I want to give it all the help that I can. So I'm happy with the position. Everything is centered up, locked down. Let's see how it works. Doing a lot better now that we're down in a ways. I got most of my chatter when we were still punching through the top side of the collar. Everything's more equalized now. Stop and clear chips. Back into interrupted cut now. We're cutting just down the side of the bushing on the back. Sounds like we made it through. And this is why I don't usually like to use cutting oil and cast iron, because you get so much of that gummy stuff that sticks. But, all right, we know we can do it. So I went ahead and drilled a second hole off camera. You all know the routine by now, so you don't need to watch every one. I also made a temporary pin. This is just an insurance policy that's only going to be used right here at the start. So it'll go in the open hole that I'm not working on. And there we are. We'll have to just give it a little tap. Yep, it's in place. It's got threads on the top in case it tightens in. I can run a nut down and pull it back out. And this is just to ensure that we don't get any rotation on the splined hub as we are tapping the threads over here. As tight as this is, it shouldn't be needed, but it's better to have it and not need it. So I'm going to clean up the top of the other hole over here with the countersink. Looks good. That helps the tap to start a lot better too if we have a nice even hole and we get rid of the slight step that there was between flywheel surface to the splined collar. I've got a better tap to use than this. Trouble is, well, the text line is the first problem. The trouble is my better tap does not have the point in the top to be able to guide it. So we're just going to initiate threads with this one, and then we'll switch to the better one. All right, good spiral tap. Now we're cooking. It's so sharp though, I just have to gently find the threads. There we go. With this type of spiral tap, you're not supposed to have to back it off to clear chips like I'm doing here. But being that we are in cast iron and steel at the same time, and they both cut very differently, I've found it works best to just keep backing this off, and it's like it just self-clears. I've also got some cutting oil in there as well, because the last thing we need to do right now is break a tap. And I didn't just say that out loud either. I was thinking it. I didn't say it. First threaded hole done. Looks good. That means we don't need the pin anymore. So we're finished with that. And we'll throw a temporary bolt in on this side. This is basically like our new pin now. I don't foresee this moving at all because it hasn't moved yet, but just in case, that'll keep it all lined up. So we'll do all the same steps to the other hole now. And now that we have 2 bolts in like this, we can drill and tap the other 2 holes with impunity. We don't have to worry about this hub going anywhere at all now. Those two 180 apart have more than locked it in. So finish up these last 2 and I'll bring you back. Well, everybody, we did it. We've got all the holes drilled and tapped oversized. We went from the 5/16 by 18 that they were originally out to a 3/8 by 16, and we were able to round out all the holes, take care of all the old ragged openings that were there, and I also worked on the spacing a bit to get them evened out more and hopefully a little bit more in balance. So show you all the backside as well. That came out much the same. I was happy we were able to carry the threads on up in an interrupted cut up the side of that new splined hub, and they all landed in just the same place. So now we talk about, pardon me there, the new lock bolts, Dutch key bolts, whatever you want to say. So I started off looking at a grade 2 because I wanted something that was going to be soft, I could stake in and deform easily, but I found the quality of these bolts is just subpar. I couldn't find anything that was straight enough to thread in. Tried repairing threads, none of that worked. So I abandoned those and I went to a grade 5. Okay, a little bit harder than I wanted, but we got the quality, the uniformity, all that is there. So then I started doing some experiments. I started purposely weakening the bolt on the straight shank below the head, right up on top of the threads, because what I want to do is create a bolt that will shear itself off at a certain torque, all right? Because I'd like to use the hex head to drive them on in. We're going in from this direction. I started at 0.200, and that was a little bit too heavy yet, so I went down to 0.150, like this one right here. You can see pretty skinny point on there, but that tightened in right where I wanted it. So here's what we've manufactured. I've got 4 of them, and they're all the same. So we've got the pre-weakened shank below the head. We still have the hex portion that we can turn it in with, and I even hollowed out the backside to aid in the peening process because that's where the majority of that is going to be. I left just the start of that non-threaded shoulder above the threads because that portion is what is going to tighten in and create the interference fit on this side, and then we go to the back side, we'll mash that over the rest of the way around where it's sticking out opposite of the collar wall. So we're going to Loctite those as well. Might as well get them put in. Normally I'm rather sparing with the Loctite. Not today. We've got cardboard down. It'll soak up anything that runs out. All right, now we just twist the head. Just like that. Worked very well. We'll peen on both sides of the collar because we don't want to allow rotation in either direction. Even with just the top threads mashed over, they're going to have to bite into the threads that are in the sidewall of the collar to move either direction. So we've got them pretty well locked in just by doing that. Plus we've got the interference shoulder on the other side back there as well. So these are going to have to work pretty hard if they're going to move in or out. So we'll work around to all four, get this step done. And we'll throw the crankshaft flange template up one more time just to be sure. Plenty of room inside. So our new setup is going to fit just fine. And one final time under the milling machine because we have to flush all these out so we have a nice flat surface for that bushing support plate. I had the perfect shot. Somebody texts. That phone. All right, that's how I tell if we're low enough or not, and it is good. Finish out the other two, and we can call it a day. Okay, everybody, I thought of one more thing, and I just have to do it. Test time. I can't really see. There we go. Can't see the splines very well, so it fits. Doesn't feel like it's tightened up at all. So there it is. I'm happy with it. Flushed out very well. We've got a nice flat surface for the bushing support plate. And I'll also mention this plate is locking a lot of that stuff in to a certain extent because we put that lip on the center splined hub, so it can't go that way. It can only come back this way, but this is blocking it. Along with the peening that we did on these lock bolts on the backside, plus the interference fit at the top, plus this also over the top of them. Everything's going to be pretty well retained in here. So we might as well give the flywheel bolts a place to live for now. These other two holes are alignment dowels. All right, it all looks good. So I'm tired. The last 3 episodes have been a lot of work and a lot of really tedious work. I've been dreading this part of the job ever since I first learned I was going to have to do it several years ago now. So, so far I'm happy with it. I won't really breathe easy until we've got that flywheel on the engine and we can slide the engine onto the chassis and all those shafts and everything line up and nothing binds and everything is happy. We'll cross that bridge when we get there. For now, I'm just happy to have it done. So it's been another long couple of days, but well, progress is progress. We'll move on from here. Thank you everyone for watching. I hope to see y'all back again.